Okay, let's take a look at 3 specific cases of solving linear systems by graphing and see what we get. We've got the standard form here in our first example for the first equation and the slope-intercept form for the second equation. And you can see that on the other examples we've got a couple more slope-intercept form equations, another standard form, and finally a last standard form there. So let's go ahead and take these one by one and just see what happens as we graph them. The possibilities, as always, when we're solving linear systems is the following. There is either one solution to the system, no solutions, or an infinite number of solutions. And we'll take that case by case. But those are the 3 possibilities that always occur. So let's take a look at this first equation. I like to label my equations personally. Equation number 1, I'll even use a different color for this one, and equation number 2. Those numbers aren't part of the equations, they're just labels for the equations, line number 1 and line number 2, we could say. Since the first one, line number 1, is in the standard form, I'm going to graph this by trying to find the x-intercept and the y-intercept. And just to quickly remind you how to do that, if I let x equals 0, then this line is going to cross the y-axis where x equals 0, which means right on the y-axis, and that's defined as the y-intercept. If I let y equals 0, then that means wherever the line crosses the x-axis, that thing is defined as the x-intercept. So that was a little bit confusing how I just said that. Let me just put it up here. What I'm doing is I'm letting x equals 0 first, and then finding out the corresponding y value. If x equals 0, I just put my hand over it. Then it looks like 5y is equal to 15. If I divide both sides of that by 5, then it appears that y is equal to 3. So x equals 0 tells me that y is equal to 3. Again, you just plug in x equals 0 here, and you solve for y. X equals 0, y equals 3. That just means y equals 3 right here on the y-axis. That's the y-intercept. Pretty simple way to do it, especially when you're just putting your hand over it and putting a point on an axis. For the x-intercept, I'm going to let y equal 0 and then find the corresponding x value. If y is equal to 0, I put my hand over this, then negative 3x is equal to 15. Solve that for x by dividing both sides by negative 3, and that gives me x is equal to negative 5. So over here on the x-axis, x equals negative 5, I'm going to put another point and try to draw a smooth line between these things. This is a little rough without graph paper and without a ruler, so hopefully I can get the solution if there is one. Okay, hopefully that's clear. Use graph paper, I recommend. So for this one, y equals negative 1/5 x plus 7. That's in the slope-intercept form. I can say right away that the intercept, b, we call it, is equal to 7. That's the y-intercept. So I'm going to go up to 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7, and put a point. The slope is negative 1/5. And I can either call that negative 1 over 5 or 1 over negative 5. Let's look at it like this to give me instructions on where to go from this point. I'm going to go down 1 and to the right 5. Down 1 and to the right 5 matches up about here. Okay, and that blue line, since that's so close to the blue line, I suspect that that's where the blue line actually should cross as well as this one. Here's my yellow line, equation number 2. Here's my blue line, equation number 1. And I suspect that the solution is right here. Sorry, I didn't really like my 1 there. Equation number 1. I suspect that the solution is located at x equals 5, because it lines up with x equals 5, and y equals 1, 2, 3, 4, 5, 6. 5, 6. So I shouldn't be satisfied with just suspecting the solution. I should check the solution to see if indeed that matches. So let me erase part of this graph just to create some space to check my solution. check. Five comma 6. And what I'm doing here is I'm going to plug in this x value and this y value into both of those equations, and if both equations show that they are true, then indeed that is the solution. So start with equation number 1. This would tell me then that I've got negative 3 times 5 plus 5 times 6, and if that comes out to 15, then I'm at least on the right track, but remember, it's got to work for both equations. So this comes out to negative 15 plus 30, which is positive 15. Indeed, that one checks out. All right. Now check equation number 2. Plug in 6 for the y value. Is that equal to negative 1/5 times, plug in 5 for the x value, plus 7? Well, negative 1/5 times 5 is negative 1, plus 7 is indeed 6, so it does check out. 5, 6 is the solution. That is x equals 5, y equals 6. All right. Let's take a look at our next example. Y equals 2/3 x plus 3, y equals 2/3 x minus 3. Both of those are in the slope-intercept form, and you may be coming to the conclusion already, but I just wanted to point it out to make it clear. Let's graph line number 1. I'll also label my line number 2. So line number 1, I'm going to start out at the y-intercept. The y-intercept is this guy right here. And you can see that actually because when x is equal to 0, y is equal to 3. That's the y-intercept. 1, 2, 3, put a point right there. Now what I'm going to do instead of trying to find the x-intercept is I'm going to use the slope, 2/3, so go up 2 over 3, put a point about right there, and make a nice smooth line. And that's my line number 1. Line number 2 tells me to start down at negative 3 on the y-axis. Negative 1, negative 2, negative 3. Right there. And then I'm going to go up 2 and over 3, put a point, and draw my other line. And it appears that these lines are parallel. If they're parallel, they will never touch, which implies no solutions. Actually, it means there are no solutions. I don't have to just rely on my scribble, though. There is a way of knowing for a fact that these lines are parallel and that they will never touch just from the equations. I can say that right away because the slopes are the same, but the intercepts are different. If the slopes are the same and the intercepts are different, then that guarantees you're talking about parallel lines. Therefore, there are no solutions to this system. No solutions. If you want to use set notation, then you're going to use the notation for the empty set. And that just looks like this. Okay? And what that means is empty set. What set is empty? The set of solutions is empty. So you might see this in some texts, or your instructor might prefer that. But simply said, there are no solutions to this system. Let's take a look at the last example I have on this video, and that is the following. Negative x plus 2y equals 6. Let's take a look at that graph by finding the intercepts. Since this equation is in standard form, here's my super fast way to do it. Let x equal 0, basically put your hand over it. Then 2y is equal to 6. Divide both sides by 2, and that tells me y is equal to 3, so I'm going to stick that right here on the y-axis. Then let y equal 0. Negative x equals 6, therefore x equals negative 6, and that's going to be your x-intercept. 1, 2, 3, 4, 5, negative 6 right there. Okay. And then connect that with a nice smooth line. That's line number 1. And move on to the next equation. Since the next equation is also in standard form, I'm going to try that method of finding the x and the y intercepts. So let x equals 0. Negative 4y equals negative 12. Divide both sides by negative 4, and that tells me y is equal to 3. Okay, right here. Let y equal 0. 2x is equal to negative 12. Divide both sides by 2, and that tells me x is equal to negative 6, which is the exact same point as the other one. So when I connect that, one line is going to be right on top of the other. I'm just going to indicate that with another set of arrows here. And I can say that this is also equation number 2. Okay, so 1 and 2 are in fact the same line. They touch at every point. This implies that there are infinite solutions. But when I say what those solutions are, I have to use one of those equations. So yes, there are infinite solutions, but here is the answer. I'm going to say in set notation, all points x, y, such that, and then I just put one of these equations here, negative x plus 2y equals 6. And then I can end my set bracket right there. This right here is how you state the solutions. All points x, y, that's this part, all points x, y, such that negative x plus 2y equals 6. And again, the reason why this is necessary is because any point on these lines constitute a solution to the system, but all the points that are not on the lines are not solutions. So you have to constrain these infinite solutions to meet the requirements set by this equation. Okay. So if your x value and your y value, when you plug them in, satisfy this equation, it's a solution to the system. If it does not satisfy this equation, it is not a solution. Okay, let's move on to some other work.